Hello guys, this is Chemistry Hangout. I want to believe you are doing very fine. Very quickly today, I've had a lot of messages, tons of messages in my DM of people preparing for NECO GCE, preparing for WAEC GCE. I have uploaded, of course, I've uploaded the titration version of the alternative to practical in chemistry. In fact, we did 2 videos already. I've seen a lot of people comment on the video that it has been helpful, and that's why we are here. But I've received a whole lot of message as regards the SWOT analysis. Sir, are you not doing for SWOT analysis? Sir, are we not going to be seeing your prediction for SWOT analysis? In fact, some people are just writing the exam for the very first time, and even the phobia of the CBT is still on ground. So they were like, sir, we know chemistry is 3 questions, answer all. You have done the titration. Where is the SWOT analysis? Where is the qualitative analysis? And here we are today. Let me show you how the qualitative analysis is going to look like. So if you are writing exam, you are writing WAEC for next year, you are writing GCE for this year, you are writing NECO GCE for this year, any exam you are writing NAPTEP, all these are same procedure. In as much as it is an alternative to practical, if it is a chemistry practical, we have a lot of that on the channel, you can learn from that. But this is an alternative to practical, and don't forget, this is the CBT version. But the CBT version for chemistry doesn't stop anything, all right? Because it is still same way you write your pencil and paper, same question, same prototype, and that's what I'm going to show you today. So if you are just watching this YouTube channel for the very first time, kindly subscribe to this channel and turn on the notification bell so that when we upload any video, you are going to be notified. So I want you to calm down, sit down comfortably, make sure you watch this video from the beginning to the end, because I'm going to be exposing a lot of things that you need to know. And I'm sure that at the end of this video, you are going to find qualitative analysis very interesting, and that's why we are here on this channel. So pay maximum attention, share this video to your friends. I'm sure you have a lot of friends that are writing NECO GCE, WAEC GCE. Share it to them so that they can see it and benefit from the wealth of experience we have on this channel. We are always wanting you to do well, and that is our priority, and that will not stop. So sit down very, relaxed, grab a popcorn and follow me. It's going to be an interesting class. Now let's go. If you look at this is the exact way that the chemistry alternative to practical looks like, because it is just copy and complete. So they expect you to know some of these things. I've done a video on this. I think it is in the membership video. If you are doing GC and you want to get access to that video, you can private chat me. So you can chat me on WhatsApp so that you can have access to that video. It will still make you understand this thing I'm doing. Especially the people that are writing this exam are SS2. A lot of them are SS2 students, and if you are not very careful of this, you are not going to get it right. So I'll just try as much as possible today to explain explicitly, all right, so that you can now just give you one to do to try, and from there you gain confidence from what you're going to do. So this is how it looks like. If you look at this question, they will say copy and complete this table. That's how it will look like. So which means you are going to be seeing this thing on the system. So you are going to complete this very particular. You are going to write down all this thing here into your booklet and then complete it. So the CBT doesn't affect anything. Your own is just write this out from the system, then in your booklet you complete it, and that's all. Very simple. All right. So if you look at this, the normal way we do qualitative analysis, if you have been following my channel, we are going to have tests, we are going to have observation, we are going to have inferences, and that's qualitative analysis. But because for every test, something must be observed, and from everything you observe, there must be an inference. There must be what is the meaning of what you have observed, and that's what they are testing us on. So follow me. Now, for people that are not very familiar with qualitative analysis, what you are interested in is the reagent. Sodium hydroxide is sodium hydroxide. Ammonia is ammonia. Barium chloride is barium chloride. And if they are present in a particular reaction, the test, if they are present in a particular reaction, the reaction that we give everywhere is the same. And that's the techniques for qualitative analysis. You are more concerned with the reagent, because every time they use that reagent, the test, every time they use that reagent, the observation can never change. I don't know if you are getting me now. Anytime they use a particular reagent, anytime they use sodium hydroxide and there is white, there is something that is present, it doesn't change. in as much as it is sodium hydroxide. So what you need to notice in qualitative analysis, especially because it's alternative to practical, is that you note the reagent. What are those things reacting with? When you know what those things are reacting with, then we can tell their observation or we can tell their inference. So come closer, let's see something. Now if you look at this, they said X, that's an unknown salt, plus what? Plus sodium hydroxide. Did you see that? It's reacting with sodium hydroxide in drop and in excess. Now they have omitted the observation that if a particular salt is reacting with sodium hydroxide in drop and in excess, they omitted the observation. Did you see? They omitted, but they give us the inference that what will be this observation if this is the inference? Did you see? It's just like they are saying, this is the answer, what is the question? That's the meaning. So, and what you need to notice is, if you have two lines here, the two lines must be filled. If you fill only one, you are going to miss one mark. You are going to miss the mark for this. So when they give you two lines like this, it means what you have to fill there are two statements. If you put only one statement, you are going to be wrong. I want to believe that is clear. So now let's come together now. Every time you react something with sodium hydroxide, a salt with sodium hydroxide, and it gives an ion 2, the color of ion 2 in sodium hydroxide is green. Did you see that now? Every time a particular salt reacts with sodium hydroxide, and the inference we get is ion 2. The inference is ion 2. It means that the observation is that what? We have a green precipitate. We have a green precipitate. Did you see that? Now, the green that is in drop, in excess, what happens? It is insoluble in excess sodium hydroxide. Did you see? Very simple. So which means that anytime I react a particular salt with sodium hydroxide and I'm getting an ion 2, it means that the color of ion 2 in sodium hydroxide is green. While if I add it in excess, it is going to be insoluble. So I've done this video. Yes, you can private chat me so that you can have this video. I did it practically. So because if you understand it practically, you will really get this. And that is the reason why you will get all these things I'm doing in a topic in your textbook. We call it metals and their compounds. If you go and read metals and their compound 1, metals and their compound 2, you will see the characteristics of all those things in this reagent. Did you see that now? So some people will say dirty green, but you are a student. Green is green. Of course, I'm supposed to say dirty green plus green, but don't worry, green, just write your green. You are going to be awarded the mark for it. So don't forget, I'm using sodium hydroxide and I have ion 2. I'm going to have green precipitate, alright, and it is insoluble in sodium hydroxide. Did you see I filled the two space? And that's all. So you need to get used to all these things. The next one, look at it. Another salt plus barium chloride. Did you see? It is the reagent that I'm interested in. The reagent that I'm interested in. They said a particular salt reacts with barium chloride. Did you see? Plus dilute HCl in drop and in excess. The first thing gave them a white precipitate. If you have been watching my channel, I have done some of this salt practically. So X plus barium chloride plus dilute HCl in drop and in excess. If there is a particular salt that is reacting with barium chloride, there are 3 radicals that are likely to be present. White precipitate, it could be SO4 2 minus, CO3 2 minus, or SO3 2 minus present. Did you see? So if I am working with barium chloride and there is a white precipitate, is either I have SO4 2 minus present, or I have CO3 2 minus, or I have SO3 2 minus. In as much as it is barium, you can see that's what I'm underlining the reagent. Anytime you are seeing this reagent, this is the observation and this is the inference. It doesn't change. It has been like that for ages, and the theory still stands. So white precipitate, it will give either of these 3. Now let's come back now. That's a plus dilute HCl in drop and in excess. Precipitate is insoluble. If the precipitate is soluble, the 2 that will be there is this. If it is soluble, it will be this or this that is present. But since it is insoluble, it means that the only one there is the SO4 SO4 2 minus present. Did you see that now? So if I have a salt with barium chloride and it's giving me a white precipitate, PPT means precipitate, I'm just very short in it. So it means that SO4 2 minus is present, CO3 2 minus is present, SO3 2 minus is present. But if they now added HCl, because they want to know, you know, it's the three of them, we are guessing that it is the three of them that are there. But they now added dilute HCl to know which of them is there. So when they added dilute HCl in drop and in excess, it becomes insoluble. If it becomes insoluble, the only one that is insoluble in this is SO4 2 minus. But if it is soluble, this 2 is the one that will be present. Did you see? That's how you just fill in the table. You just copy and complete the table. Then we move to the next one. They said X plus dilute H2SO4 plus conc HNO3. Fe2 oxidized to Fe3. Look at something. Fe2 is now oxidized, so it's not Fe2 again. It becomes Fe3. There is a difference between Fe2 and Fe3. This is ion 2 plus. This is ion 3 plus. I've done oxidation and reduction. So there is an oxidation, which means ion 2 has changed to ion 3. And when ion 2 changed to ion 3, what is the color of ion 3? I did it in that video. Is what? It's reddish brown. It's reddish brown. Did you see? So we are going to see a reddish brown. Why? Because ion 2 has what? Changed to ion 3. And the color of ion 3 is reddish brown. Did you see that? Very simple. These are just the way we, very simple, very simple. The next one, they said solution of Y plus NH3 in drop and in excess. What do you notice again? Ammonia. Did you see? So the reagent that they are reacting with is the bone of contention here. The reagent. So solution of Y plus ammonia in drop and in what? And in excess. White precipitate. Did you see? In ammonia. This is ammonia. We have white precipitate. If you have white precipitate in ammonia, there are two likely ions that could be there. Yes, there are two likely ions that could be there. It could be zinc. It could be aluminium. You see, you are working with ammonia and there is a white precipitate. It means that the likely cations there is zinc or aluminum. You know, they can still do it like this. They can say solution of Y plus ammonia in drop and in excess, and they will give you zinc and aluminum, so you know what is there is what is white precipitate. They now said in excess, the precipitate is what? Is soluble. Now listen, if the precipitate is soluble in ammonia, it means that the only cations that is there is zinc. You know why? Because aluminum is insoluble in ammonia. Did you see? The reason why it is not magic, the reason why I know this thing is because I understand the characteristics of metal and their compounds. And if you want to get this well, read metals and their compounds. You know, when you talk about metal and their compounds, zinc is a metal, aluminum is a metal. Did you see? Iron is a metal. So when you read all those things and you now go to what we call test for iron, test for iron 2, test for iron 3, test for zinc, you will be seeing all these things there. You will see that zinc is soluble in ammonia, but what? Aluminium is insoluble in ammonia. So I cannot put aluminium here because they said the precipitate is soluble, so it is zinc. Clear, right? Then the last one, solution of Y plus conc H2SO4. This should be a familiar test. If you're a secondary school student and you see them writing NO3 confirmed, if a nitrate ion is confirmed, then you should know that it's a very common test. We call it a brown ring test. Call it a brown ring test. That's why you are here to learn. So don't forget, anytime you are seeing NO3 minus confirmed, triazonitrate 5 confirmed, the observation is a brown ring test. And this is just what likely questions that you are expecting. Just copy and complete. Does this make any sense? Did you see? Very clear, very easy. Let me do another one for you. Then I'll give you this. I'll give you this to try. Alright, I'll give you this to try. From all what I've been saying, you are going to try this. Now let me quickly put an answer to this so that you can work on this for the few weeks that your exam is ongoing. They said A plus heat, colorless, odorless gas, turn lime water milk. If you're a secondary school student, you give me the answer to this. What turns lime water milky? Colorless, odorless gas, which turns lime water milky. What happened? That's a CO2 gas. CO2 gas from HCO3 minus or CO3 to. Did you see that? So because this is CO2 gas, you can liberate CO2 gas from this HCO3. Did you see? And you can liberate CO2 gas from CO3 minus. So this is even a confirmatory test. It's a confirmatory test for CO2. The gas that turns lime water milky CO2 gas is a confirmatory test. Did you see? So they are asking you what you have known before. But some of you will not understand that this is the way they are asking you. A colorless, odorless gas which turns lime water milky CO2. There is no any other discussion. It's CO2. That's a confirmatory test for CO2. Alright? So look at this. Residue from this plus water plus litmus paper. Look at something. Look at something. Dissolve to form a colorless solution which turns red litmus blue. Did you see? If something turns red litmus blue, what is that? Is it acidic or basic? If something turns red litmus blue, is what? It's basic. So when it turns blue litmus red, it's acidic. This is how you fill the space that you have. Just read the question from your chemistry knowledge and when you have learned on this channel and in your school, you can always get these things right if you practice it. So, dissolve to form a colorless solution, turn red litmus blue. So if you turn red litmus blue, you can say, look, the solution is what? Is basic. The solution is basic. Why did we say the solution is basic? Because the solution turned red litmus paper blue. If the solution turned blue litmus paper red, they will say the solution is acidic. Did you see that now? Alright. I want to believe you are still seeing the board. So let's move on. Look at this solution from this plus, look at that. Sodium hydroxide in drop. Solution of this plus sodium hydroxide in drop. No, they didn't give me this, they didn't give me this. Did you see? But they gave me an int. What is the int they gave me? Calcium is here. So, and I know for them to have gotten that because this is the same, they added this to sodium hydroxide in drop and in excess. So if it gives me calcium, it will give me an hint of what should be here and here. So in as much as there is calcium here, what I will add is that plus sodium hydroxide in drop, it is going to give me a white, chalky precipitate. Why will it give me a white chalky precipitate? Because that is the behavior of calcium. Calcium and lead, they are chalky. They are white chalky in sodium hydroxide. Did you see that now? So solution from plus in drop, white chalky. Did you see? So if it is white chalky, it could be calcium, it could be what? It could be lead. Did you see that now? So because I don't know which one is going to be, in as much as it is white chalky precipitate, it could be calcium, it could be lead. And also then in excess. So in excess, it gave this. So they said in excess, the inference is that it is calcium that is there. And if it is calcium that is there, it means it is what? Insoluble. In what? In excess. Did you see the way I'm feeling this? Why did I know that it's insoluble? Because calcium salt is insoluble in sodium hydroxide. That's how it works. Calcium salt is insoluble in sodium hydroxide. Did you see that now? The next one, they said B plus water, soluble salt. If something is a soluble salt, what is the meaning? It means it dissolves completely in water. Did you see? These are basic things. It's just like what you know. Write it for us, let us see. So B plus water, they said it's a soluble salt. The meaning is that it dissolves completely in water. So the meaning is that since it is a soluble salt, what if it is insoluble salt? It will mean that it doesn't dissolve completely in water. I want to believe this is clear. The next one, let's go. Solution from D plus sodium hydroxide in drop, then in excess. Look at something. Solution from D plus sodium hydroxide in drop and in excess. White gelatinous precipitate is different from white chalky precipitate. Did you see that one? Did you remember I have said something about this sodium hydroxide? I come to the one I did before. Look at that. Sodium hydroxide. Where is it? I think I did. Okay, I did for ammonia. Now this one is for sodium hydroxide. Okay. So for white gelatinous precipitate, if it is for sodium hydroxide, white gelatinous precipitate, there are two ions that are likely to be present. What are they? They are zinc and what? Aluminium. Zinc and aluminium. So Note the difference between white gelatinous precipitate and chalky. If it is chalky, that will be calcium and lead. Alright? If it is white gelatinous precipitate, that will be zinc and aluminum. So solution from D plus sodium hydroxide in drop, then in excess. White gelatinous precipitate form. So if it is white gelatinous precipitate, we have zinc, we have what? We have aluminum. Did you see that? Present. Let me just erase this and put present. Then I will underline it back. Did you get that now? So if I'm working with sodium hydroxide, in drop and in excess, and there's a white gelatinous precipitate, then we have zinc and aluminum. I want to believe that is clear now. Then in excess, precipitate is soluble in excess. Did you see that? Precipitate is soluble in excess. If the precipitate is soluble in excess, because aluminum is soluble in sodium hydroxide, yes, it is. So solution from this plus sodium hydroxide in drop, white gelatinous is either it is zinc and aluminum. If it is soluble in excess, it could be because zinc is soluble in excess, sodium hydroxide, aluminum is soluble in excess. But now let's come now. Look at this. Solution from D plus Na3 in drop and in excess. You see aluminum. So which means in drop and in excess. Come back. Did you see something now? Look at the one before. Please bring the camera here. Look at the solution of 1 plus in ammonia in drop. You saw they gave us white precipitate here. What did we record? But now we have this. So I can infer now that this will be white what? White precipitate. Did you see? This will be white precipitate. Now you say in excess. I just told you that aluminum is what? It's insoluble in excess ammonia. I said it here. Because this one they said precipitate is soluble. That's why we had zinc. Please bring the camera so that they can see what we are saying. So precipitate is soluble. That's why it's zinc. So zinc is soluble in sodium hydroxide, still soluble in ammonia. But aluminum is soluble in sodium hydroxide, but insoluble in ammonia. And we could even confirm it because I already said only aluminum. So if it is only aluminum, what happens? It is what? Insoluble in excess. I want to believe somebody is learning here. So it's insoluble. So if it is insoluble in excess, then it is aluminum. Because aluminum is insoluble in excess ammonia. Did you see that? Then the last one before I will now give you, so I will put the camera there for you to write it and you know do it yourself. So it's a very simple test. If you follow all these things and you practice it, you will get one of these things on that day. Then the last one now, solution from D plus AgNO3. Please note this. AgNO3. Anytime you see this is what we use for testing for silver. And that's why you can see they are repeating. It's testing for chlorine rather. Chloride ion. Most times, chloride ion. That's why they are repeating it. So if you add any solution to AgNO3, what will happen is that you are going to have a white precipitate. You are going to have a white precipitate, and this is what is present. So if we go further and add HNO3, did you see that? HNO3 is going to be insoluble in HNO3. Please note all these things. It's insoluble in HNO3. If it is insoluble in HNO3, it is chlorine that is present. If you don't want to confirm, that's why I say, you saw the Cl confirm. So if we want to confirm this, we are now going to add ammonia. When we add ammonia and it is soluble in ammonia, if it is soluble in ammonia, then this is confirmed. Let's get that very well. Note that AgNO3, anytime you see it, you are just looking for chloride ion. So, and that's white precipitate. On the addition of HNO3, is insoluble in HNO3, then chlorine again is going to be present. Then if you add ammonia, it's going to be soluble in ammonia and chlorine to be confirmed. And that is it. Did you understand? So these are same thing. Yes, these are same thing that you need to just practice it. And that's why I took my time to just do 2 samples for you so that you can have a lot of things to read and you can search your different questions. You can join the WhatsApp group too so that we can send some that you can practice. But look at this, you can practice this and put some of the answer in the comment box section. Look at that test, observation and inference. X plus NaOH in drop and in excess. There is a fill in the gap here you need to do, and they said copper 2 plus is present. So what will be here? What will be here? S plus ammonia in drop and in excess, this. So nothing is here, nothing is here, nothing is here. You have to fill it, and it can come like this on that day. S plus barium chloride, then followed by what? White precipitate. Nothing is here, nothing is here. Did you see? So Y plus H2O dash, Y is a soluble salt. What will be here? Then Y plus sodium hydroxide in drop and in excess. Y gelatinous precipitate. Nothing is here. You know, just take a look at it. You can put it for some minutes so that you can write it properly if you want to write it. You can share this video to your friends. Share it to your friends. It's going to be an interesting one. They will like it and they will actually thank you for, you know, sharing an educative and informative content like this to them. If you are not on the WhatsApp group, you can just, you know, you can join via the link. I'll put the link in the comment box section so that you can take a snap of this and send it to the WhatsApp group, and you can have, you know, you can have access to it. And I said I've done a particular video on qualitative analysis. If you feel that you need it, you can private chat me too. Then we are going to drop a link in the comment box section, or just look for a number around the video and chat us on WhatsApp. We will likely give you access to it so that you can use it to prepare for your exam. So now if you are doing chemistry exam, don't forget titration is sorted now. We have 2 videos on that already. And qualitative analysis too is sorted now because we have 2 samples and even a sample question for your qualitative analysis. So you are writing GCE WAEC, you are writing NECO GCE, you are writing NAPTEP, you are writing out those exam and the alternative to practical. Then this is for you. If you are a teacher too, you know, a lot of teachers has reached out to us for our laboratory reagent video. There's more than 400 teachers across Africa has gotten it, and the review has been wonderful. So if you are a teacher and you want to get access to that video, we will likely give you access to it so that you can chat us, so that you know what to do, so that you can have that video. I love you so much. Thank you so much. I wish you guys success in your exam. Don't be afraid. These are just likely things you are going to get. They are likely things you are going to get. And if you have been following our videos and you have been studying dutifully, then you should not have problem with the exam. So till we meet you again, we love you. Stay chemically active. We wish you success in your forthcoming exam. Thank you and God bless you.